Okay, let's try this video again. It didn't work last time except for the very beginning. Excuse me. Thank you for those people who let me know that the audio wasn't there. I don't know what happened, but anyway, so here's section 11.1, and we're doing the distance from a point to a line. And I don't remember exactly when we did it, but we had some problems, and I think there were more in the section when we were doing something in the parametric we were just doing, and we came across and we were able to derive that equation for the point to line. I think it was in as we were doing those last ones, right? So we've seen that equation. We've seen the equation for ourselves. Okay. Now the book goes into they go through a derivation of this, and just to kind of show it, it's a different way, and you know what, it's a great way. And I showed through the book how they did it last time, but I can just show you here, right? Just to make it easier, because I don't have the book right here. So we have a line, and it doesn't matter where the line is, okay? And this line has the equation. We'll say it's in y equals mx plus b form, okay? For ourselves, there's our line, okay? And here's our point that's not on it, and we'll call that x0, y0. That's our point for ourselves. I don't want to. I can call that a. I guess I can call that a. Okay. And so here's the distance. Right here represents the is a visual interpretation of that distance. All right. I'll put a d on there. Okay. And I'll name this point d. Right. Just for the distance. Okay. For ourselves. Now we also have, because we have a line here, if I were to pick a point, we'll call that E, and then we're going to go to another point, right? To get from point E to G, we could say, we can place E and G so that this was one space and this was M. Because remember, my slope here is M over 1, right? Rise over run, right? That's where that's coming from, okay? So if we also were to draw a triangle coming straight down here, so that that's perpendicular, and I'll call that point C right here. Okay, and I'll call that point B. Okay, we could say that these two triangles are similar. Now, you want to say to yourself, well, how are those similar? That doesn't make sense to me. And once we think about it, it will make sense, because hey, look, those are right angles, so at least we have one angle. And then remember that these are perpendicular to each other, so so that this line is perpendicular to this. So we know what the slope of this line is. The slope of this line is 1 over m, right? So since this is perpendicular, right? Then it would follow that, hey, wait, since that's perpendicular to that one, right? We can say that this angle here and like this angle is congruent to that, and that's congruent to that because of the perpendicular aspect to it. Okay, for ourselves. Right, just coming from the fact that, hey, this is vertical for ourselves. If we were to slide this down and put it right here, we could see that this angle, if this pink was drawn right here, these two angles would make a right angle for ourselves. So these two angles would add up to 90, and therefore, and these two angles add up to 90. So we can see that there's congruent angles for ourselves. So that's why we know that those two triangles are similar to each other. Okay, all right, triangle ABD is similar to triangle let's see, ABD, and then it's going to be E, and I don't have, we have an F. I think the book uses an F there, so we'll add that F there. Whoops, I should just try to keep color coding. All right, and then triangle E, let's see, this one ABD, so it's going to be EGF. Okay, so because we have that, they're similar by angle, right, and I could go something like this and mark those, right, to show that angle. Okay, then it would follow that AB is to EG, okay, as AD is to EF, and we could also do the third side, but we're not going to, right? There's a reason. We have what we need from this proportion that we have here, okay? So if I can replace EG, if I'm looking at EG, I can figure out that length because there's a Pythag here, right? So EG squared equals 1 squared plus m squared. So this is going to be the square root of 1 plus m squared. Okay? And AB, if we look at that, AB is just AB. Okay. AD is our distance, so I'll replace that. EF, if I look at that, hey, that's just 1 there. Okay, so we get one of our distance formula in one form would be distance equals AB over the square root of 1 plus m squared. Okay, so that would be a distance equation we could use. Not that we'd really want to, right? But we could use it. Now, here's how we're going to turn that into a usable formula for ourselves. Okay, so if we look at AB, right, we can see that AB equals AC minus BC. And hopefully that makes sense to you. Hey, look at that. That's the whole segment. That's segment addition back from geometry there. Okay. Now, the length of AC is the y value, because it's coming right off the axis. It's the y value there for the point. Okay. And BC right here. Okay. Well, that's the y value of at this point. Okay. What is the y value at that point? Oh, this is my equation. So if I plug in the x value, that will give me the y value there. Okay. Right, so there's our expression, right, for here's what we can replace AB with, right? How is that better? Well, because now we don't have AB in there, right? We've gotten rid of the AB, so now we can have y0 minus mx0 minus b over the square root of 1 plus x squared. Now, one of the things we have to keep in mind, this was a distance for ourselves, and wait a sec, what if this was going the other way? We don't know which of these two is larger as we do it. So we're going to throw some absolute values on it, so that it's always going to be positive there, right? And that's just to make sure that we don't have a negative distance for ourselves. Distance is a magnitude for ourselves, okay? And you know, we have this form, and because this could be negative, we can rewrite it, change the signs of all of them, and then you'll see the formula that you see in the textbook. Right, for yourself is going to be, notice every single sign changed. I multiplied everything inside by negative there, because that doesn't matter if you multiply by negative, because you're going to have that absolute value. So this is the formula you see in the textbook, right? And really that's just, an alternate form for ourselves. That's like, hey, if I want to memorize two different formulas, I can. Right? I'll be honest with you, I've never bothered to memorize that one. I am just going to always go with this one here, right? I like this one over this one. Why do I like this one? Because it's basically general form with the x's plugged in, and then to take the a and the b, right, and to square them to put them in right there. So, in my opinion, that's the best form to use. Okay? How would I do this with an example? Well, at this point, this is something pretty similar to what we've done. Okay? So, we're going to find the distance from a random point. Let's call that point negative 2, 5. I'm going to do the same examples I had before in the other video. To the line y equals 3x minus 4. Okay? So, since it's in that form, I could choose to use this equation, but really, I'm going to tell you guys, I'm really not going to. I'm going to always go with that other form. It doesn't matter. You're going to get the same answer either way. But if I'm trying to minimize my memorization, I'm going to change that to 3x minus y minus 4 equals 0. Right? And then I'll go right in and plug it into my formula there. And see that, a times the x value minus 1 times the y value minus 4. All of that over, right, 3 squared plus 1 squared. I could put it as negative 1, but I know it's going to go away. Right, I put this all becomes 15. I get 15 over root 10. That one looks like it's going to reduce. How do I know it's going to reduce? Because 15 and 10 both are divisible by 5, so I'm anticipating that reducing. So I'm going to multiply top and bottom by root 10, which gives me 15 root 10 over 10, and I get 3 root 10 over 2. And some people say, do I have to do that? If a radical can reduce, you should try to reduce it, and that is, the fact that this could have reduced for ourselves. That's a better version. I don't know. It's not the main focus of this problem, so if you didn't do it, I'd probably still give you full credit for that one. Okay? If I plug it into the other formula, it would give me exactly the same answer, right? You'd eventually get to that. And if you want to try it on your own, go right ahead, try it on your own. Okay? So, next example that I did, if you saw it on the other notes, example 2. Okay? Right? Find the equation of a circle that has a center of 3, 4, and that is tangent 2, and then we just have a random line here. Let's do that, okay, for ourselves.
Hey.
Okay. That's Josephina, right? Everybody say hi to Josie. Right. Josie, can you stir dinners, please? Okay. Can you stir the dinner, please? Okay. So, let's see. So we're trying to write the equation of a circle, and hopefully you remember, right? And we had it on that other video I gave you. We have that as the equation of a circle. Okay? And we know where the center is, so we can plug that right in. Okay, we just need that radius. So the radius, if we think about this, we have a circle here and we have a line. Okay, the radius is going to be perpendicular because it's tangent. We may or may not remember from geometry that these are perpendicular, right? Hey, look, that distance is the radius, right? So I just have to get that radius there, and I just have to get that distance there. So I'm going to change this to 4x plus y minus 1 equals 0, right? Moved everything to the left, right? So basically, I'm all set up, right? 4 times 3 plus 1 times 4. Minus 1, all of that over the square root of 4 squared plus 1 squared, okay, so I have 12 plus 4, right, so 15, right, for myself, and that's over the square root of 17, so that's my distance there. Remember that my equation wants it squared, so I'll square that, and I'll get the 225 over 17, right, as my equation of the circle. Okay, it doesn't tell me I need to distribute it. It doesn't tell you to say anything about what form it has to be in there, right? So I'm good to go. Okay, so those are some examples. Check out the other video for the rest.